So in continuation to our last lecture, today we are going to take spherical mirrors, and you know that we were doing reflection. So today's topic will be reflection through spherical mirrors. Now, as name indicates, these spherical mirrors are the mirrors which are made out of a sphere. Now, you can just understand like this. Suppose you have a sphere. This is transparent glass hollow sphere. Now, if you cut one piece out of this, suppose this is the piece we have cut, and you take out this piece like this. Now, we have two options. One option is that we polish it from the raised portion, that is the bulging portion. So in this case, the curved portion becomes shiny. Then second choice we have, if you take the same piece here again, the second choice we have is we can polish it from the curved surface, the curved side, and the bulged side, or you can say the raised portion, become the shining one. Now, on the basis of these two options, the spherical mirrors are of two types. First is concave spherical mirrors. So spherical mirrors are so called because they are the small parts of a sphere, and hence they are called spherical mirrors. And mirror, why mirror? Because they are polished from one side and the other side is ready for reflection. Second, so if suppose the portion of part of the sphere, if it is polished from outside, that is the raised portion, then the inner portion becomes shining. This is called concave. This is concave. This is concave. And if the inner portion, the curved portion, is polished and the raised portion is shining surface, that is from where the reflection will take place, then it is called convex. So on this criteria, there are two types of spherical mirrors. One is concave spherical mirror and second is convex spherical mirror. Now, when we talk about the spherical mirrors, there are certain things which we need to understand. So, if suppose this is I take concave spherical mirror, because concave spherical mirror is convenient to use and widely used in our day-to-day life. If suppose this is the concave mirror we have, so you can see from a raised portion it has been polished, from inner side it is shining. That means the reflection may take place from this side. It is ready for that. Now, if suppose two ends of this mirror I write as A and B. So this A and B, the separation between A and B, this is called aperture of mirror. This is called aperture. Aperture of mirror. Now, if you take the geometry, and you know that this is a small part of a big sphere. So that sphere from which this piece has been cut, suppose this is the center of that sphere, and this is called center of curvature of this spherical mirror, that is concave spherical mirror, and this is represented by C. Then if I take the geometrical center, if I just divide this mirror, which is a small part of spherical mirror, of a sphere, if you take this central point, this is called pole. This is represented by P. Now, if I draw a line through center of curvature and the pole, then this is called radius of curvature. Pole is represented by P and center of curvature is represented by C. Now, if we see all these things, this line which is passing through the center of curvature and is passing through pole, this line, and this line can be an indefinite line. This line is called principal axis. This is called principal axis. So these are some of the terms. Now, you know, laws of reflection which we have studied in the last lecture. The first law says that angle of incidence is equal to angle of reflection, and second it says that all these, that is the incident ray, reflected ray and the normal, they will always lie in a plane. Now you must have studied in mathematics class 9th, any line which is drawn or passing through the center and hitting any point of the sphere. You know, this mirror is a part of a sphere. So suppose any point you have x, and on this x you draw a line which is passing through the center of curvature. This is going to be normal at that point. You must have, when you measure the angle between the line and a curved portion, then the rule is that you draw a tangent at that point, and this angle is always 90 degree. So this becomes a normal. So principal axis in that way is a normal. And how many normals can be drawn? There can be infinite normals, because there are infinite points along this mirror, and there can be infinite lines passing through the center of curvature and hitting any point of the mirror, and all those will be acting as normal. Now if you have a ray, suppose this ray of light is coming, okay, then what will happen? This is angle of incidence, because this is behaving like a normal. This is angle of incidence, and this ray, according to the law of reflection, which is equally true for spherical mirrors, this will pass, this will be reflected and will pass like this, and you know, this will cut this principal axis at a certain point, and this point is called focus, right? So a ray which is moving parallel to the principal axis, hitting the mirror at certain point after reflection, and following the law of reflection, that is this angle will be equal to this angle, will cut or intersect on this principal axis at a certain point, and that point is called focus. And the distance of this focus from the pole, this distance, okay, that is, you can say P and F. This is called focal length. This is called focal length. This is called focal length. Right? And generally this is represented by F. So you can just see these in the PPT also, these terms. So I just review it. Spherical mirrors are so called because they are the small part of a sphere. Are of two types. The spherical mirrors are of two types. One is concave mirror and second is convex mirror. You have seen, just we were discussing, again you can see, if it is polished from outside, then it is concave mirror. If it is polished from inside the curved portion, it is convex, right? That is what it written here. So spherical mirrors are of two types. One is concave mirror, other is convex mirror. In concave mirror, spherical mirror that has its reflecting surface curved inwards, right? Means the inner side curved portion is shining surface. And convex mirror is that mirror, that is spherical mirror, which has reflecting surface towards outward, that is the raised portion, bulging side. Then there are certain important terms in spherical mirrors which we have discussed. One is the center of curvature. Center of curvature is the center of that sphere out of which you have cut that small piece, and that piece which you have made as concave or convex mirror. Then focus. Focus is what? Focus is, you can just see here also, I have drawn for you. What is the focus? Suppose this is what I was discussing. So this is concave mirror, this is pole, this M and M dash is aperture, this is the center of this sphere, this is called center of curvature, right? Now, then there is principal axis. So what is principal axis? See, principal axis is this. It is written principal axis. The line which is drawn indefinitely passing through the center of curvature and the pole. This is called principal axis. Okay. Then pole. Pole you have seen. This is the pole. Pole is what? A geometrical center of the mirror. It may be a convex mirror. It can be a convex mirror. It can be a concave mirror. It doesn't mean. The terminology remains the same. Right. Then pole, focal length. Focal length also we have discussed. Focal length is this. It must be in the next. Now see here, I have shown. These are parallel rays. After reflection, they are meeting at this point. So this becomes focal focus, and the distance of this focus from the pole is focal length. Right? So focal length and radius of curvature is what? Radius of curvature is this distance. That is distance of center of curvature, which is the center of the sphere from the pole. So these are certain terms which we need to see. So these are two types of mirrors. One I have drawn convex and one I have drawn concave. From the same sphere you can make convex as well as concave mirror. So these are the definitions which I have already told you, right? You can go through. I will be sending this paper to you all, right? And then we have also discussed this. Now, you know, now in this case, you see the focus is on the same side from where the rays were going. But in this case, you see this is a convex mirror. Now, because this will be a sphere, the center of the sphere will be somewhere here. I draw a line, this becomes normal. This is the parallel ray to the principal axis, because this is the line which is passing through the center and the pole. So this is the parallel ray. Now this ray is will be going to this side, not this side, because this is the principal axis. This is the principal axis. See, dotted line I have shown. So this will go like this. So after the reflection, it is going away. It is diverging. See, similarly here, it will diverge this side. So they will meet, if they are extended to the back side, they will meet at this point. Now in this case, in case of convex mirror, the focus is on the other side, where the actually rays are not meeting. Rays are appearing to meet at that point, and this type of focus is called virtual focus. So in the case of convex mirror, the focus is virtual, whereas in the case of concave mirror, it is real, because actually all rays after reflection are meeting there. So one is the principal focus of the convex mirror. It is the point on the parallel axis where the reflected ray appear to converge. They are not converging, they are appearing to converge when you extend it that side. Focal length of spherical mirrors. Now what is the focal length? I told you focal length is the distance. In this case, now here they are appearing to meet, so this becomes focal length. In this case, this is the focal length, right? Now we move forward. Now, you know, in last lecture also we were discussing the image formation. And image formation is by virtue of reflection. And there are certain rules which we follow in order to make the images. Now we'll be discussing how the images can be formed with the help of concave and convex mirror. As I told you, we are dealing more with concave mirror because these are widely used in our day-to-day life, and visualization of image formation is easy in the case of concave mirror. Now there are certain rules how the images will be formed in mirrors. Now this is a concave mirror I have taken. See, already we have discussed any ray which is going parallel to the principal axis will pass through a point, and that is focus. Now here, any ray passing through the focus. Now suppose I reverse it. A ray passing through the focus after refraction will become parallel. Right? So in law of reflection, if reflected ray is made incident ray, so incident ray will become reflected ray. Right? Similarly, in this case, a ray going parallel will go outward and will appear to meet somewhere here. So this becomes focus. Right? Now, then any ray which passes through the center of curvature will go back. Why? Because any ray which passes through the center of curvature and hits the mirror is actually passing through or is moving across the or moving along the normal. So angle of incident is 0. So angle of reflection has to be 0. So it will come back like this. So any ray passing through the center of curvature after hitting, after reflection will come back. Then any ray which hits the pole will be reflected back according to the law of reflection in the same angle. Because in this case, principal axis is behaving like a normal. And I told you principal axis is one, normal on the mirror. Like we have so many other normals, right? So there are 4 rules. See, first rule is parallel after reflection passing through the focus. Second rule is any ray which passes through the focus becomes parallel, reverse of this. Third is any ray passing through the center of curvature after hitting will come back, will pass through the center of curvature and go back. And the fourth rule is any ray which hits the pole will be reflected back at the same angle, principal axis is acting as a normal. So out of these 4 rules, if we follow any 2 and we use in any situation, we can find out how images will be formed, right? Now let us take formation of image in the case of concave mirror. In the case of concave mirror, as we were discussing, the image formation can be understood by keeping the object at 6 prominent places. Okay, and this is what we will be studying in the next lecture, that if I keep any object is whose image we want to see or what we want to see after the reflection. So these are 6 prominent location. These are 6 prominent location at which we can keep the object, and we will like to see that where the image will be formed and what is going to be the nature of that image. And this we will deal in the next lecture.